also. Yeah. So, am I audible? Okay. Let me just zoom in. Yeah. So screen okay. So how's everyone doing on assignments? And I see nobody submitted week 6 assignment. Is everything okay? Yes, time series assignment is a bit tougher because it combines everything we have done till now. You submitted yesterday, Seetan. Okay. And so we did multi-indexing actually. Anyway, we'll be doing multi-indexing again. Sorry, that's my bad. I couldn't manage to upload the recordings. So today, along with this session, we upload the extra session recording also, so that everybody will have it. Okay, so I think now we could start. Everybody who should have joined is already here. Let's see how much is the attendance. Okay, more than half of you are here already. So we'll start. Uh, Today we don't have too much content, so I will go a bit slow. And if time is there, maybe we can discuss some of the problems you are facing in assignment also in the end. Okay. So this week on session 7 and 8, we'll be doing visualization in Matplotlib. Okay. Visualization on pandas, Pythons. And for that, we'll use, so there are some inbuilt function in pandas which are built on top of Matplotlib. Matplotlib is a very popular and very strong data visualization library in Python. Okay, so today we'll see Matplotlib, and in the next week we'll see Seaborn. Seaborn is an extension of Matplotlib. It's like more fancy, like the charts and graphs looks much nicer and cooler in Seaborn. Okay, so and it's also a bit more easier in Seaborn. So we'll see Seaborn also in the next week. Okay. So these 2 weeks we have dedicated to visualization, but it's already zoomed, see the like at 125. If I zoom more than the screen won't fit. No, it's too much zoom for me. Is it okay? Is the screen visible to everyone? Okay. Yeah. So where I was, yeah. So I was saying that we have dedicated 2 weeks, like 6 hours to visualization. But visualization is very different and advanced topic in Python. Okay, so you could actually spend like whole course on visualization. There are so many things to do in visualization. But obviously we'll not be going into so much detail. So we'll do the basics so that you could use it for your projects and you know how visualization works. But obviously, like any other topic in Python, if you want to go deep, you read the documentation. When you have some problem, you Google and find out what is the best way to do it. And if you have doubts, you can put it in forums and we can discuss it. Okay. So in today we'll see some basic, like we'll see almost all kind of visualizations which we'll be using in data science with some more advanced features also. Now, what is the advantage of visualization? Okay, so visualization is a core uh, area in data science. So if you are a data scientist, apart from, so as I mentioned earlier, so when you are a data scientist, most of your time, like around 80% of your time goes into data acquisition, data preparation and all, okay, data cleaning. And then the remaining 20% is when you do data analysis. In that 20%, you spend half of your time in doing analysis by like creating some, finding some trends, finding some interesting results, and the half of your time you spend in actually representing it, those results in a visual format for your clients or for your managers who needs to understand, because visual representation is the best way to communicate different trends and different results, because not everybody could understand and grasp numbers, right? So visual representation of the results is one of the best results you could show, and everybody likes graphs and charts in their reports, right? So visualization is a very important part in data science. Okay, so what we are going to use is Matplotlib. So Matplotlib is one of the most powerful libraries in visualization. So many people use Matplotlib of Python. So they don't use Python in any other way, but just Matplotlib for visualization. Okay, because of its extreme power. So the closest competitor I think is from R, which also has a very strong visualization library. Okay, so the to work on Matplotlib, we import the matplotlib.pyplot package, HPLT. So this is like most common short name. For like pandas, we say PD. For NumPy, we say NP. For matplotlib.pyplot, we say PLT. Okay, and what we have here is matplot. So this is a magic function. Okay, so what is a magic function? So this is nothing to do with actually matplotlib. It's more like uh, IPython notebooks predefined. So in IPython, there's a set of predefined magic functions that you can call with a command line syntax. Okay, so there are like two kinds of magic functions, like line oriented, string oriented, etc. Okay, but let's not go into detail of this because it's like more about IPython notebook. But what this code is doing is it's telling this notebook. So this notebook which we are using is a software, right? Which is running our Python code and displaying these results in nice format, right? Like when we say matches.head, it knows it's a data frame, then it creates this line for you. It bolds on the column, it keeps the row index in bold and on this, so this form, and then it's spaced properly. So all this visualization is done by the notebook, right? So when you say matplotlib.init, it sets the backend of matplotlib to the inline backend. So what this means with this backend, so whenever you plot anything, the output of the plotting commands is displayed inline in the front end. Okay, so that means when you plot like here, so you just say dot plot and type of plot you want, it is displayed on the notebook. Okay, so when using inline backend, your matplotlib graphs will be included in your notebook next to the code. Okay, other alternative is you can say pnt.show. Okay, so if you do all these things and you do pnt.show, okay, this, so if you don't this matplotlib.inline magic, every time you create a graph, then you have to say pnt.show. That is, you are instructing that Jupyter notebook to show the graph you have just plotted. If you do the matplotlib inline magic function as this, then you don't have to explicitly say the show function, and whenever you say plot, it will plot and show it. Okay, so that's the main advantage. So let's start with a simple example. So this, we have seen this data frame long time back, right? So let's read the CSV. First we have to import Python. Okay, wait, this is taking so much time. So any questions till now? So everybody's convinced about the importance of visualizations? Okay, let's dive in. So what we are doing here, we are simply reading the CSV as we have seen many times. Now this is the matches CSV. So it has a record of each match, like who was the team 1, team 2, who win the toss, etc. Who was player of the month, umpire, who was the winner, etc. Okay. Now what we are doing here is a simple, we are seeing how simple it is to plot. Okay, so everybody could understand up to here, I guess. So what is this code doing? Who could tell me? So read this code. So you understand this data frame, right? So this is for each match played in IPL 2008. Which city it was played in, which date, which were the team, who was the winner team, who was the match player of the match, and some more details are there. Now who can tell me what is this code doing? Okay, I get some replies. We need to import pyplot package. Matches played by each pair. It is giving the man of the match for all the values. And how many times the player was man of the match. Yes, close enough. So what does value counts gives us? It's not matches played by each year, because it's only player of the match. Player of the match dot value counts. Unique values or frequency, right? If you remember, value counts give us the frequency. For each unique value, how many times that value came. And by default, yes, and it's count. And by default, it is always sorted. Like the highest value will come in the top. Yeah. So in simple words, it's giving the top 10 players who were man of the match. Like Chris Gale was man of the match 17 times. Pathan was man of the match 16 times. This is the top 10 players who were man of the matches. What maximum man of the match. Okay, and we are doing a simple plot of this. So what it is doing, it's plotting the player names and the number of times they were man of the match. Okay, so this is a very simple plot. We'll see in detail how to do it. Okay, so but just to show you the power of matplotlib, like it's as simple as that. That once you have the data, you can just say plot and tell it what kind of plot you want, and it's done. So it's as simple as this. Okay, so let's go into one by one. So we'll come to this graph later, but let's start with simple data points, simple graphs first. Okay, so as usual, there is a link in the notebook which has the details of this plot function, the API, and it has so many parameters, right? So if you read this whole section, there are so many details to go through it. You understand half of it, okay? But let's start with simple plot. Let's start with the simplest plot which we know, which is plot with one axis. Okay. So this is your data. Okay. So it's an array of integers 1, 2, 3, 4, 5. Okay. Now if you say pnt.plot, okay, the simplest version of pnt.plot is takes the data. Okay. This was data frames, which is pandas function, which will come to later. We're starting with the basic pyplot now. Okay, matplotlibs. So you say pnt is our matplotlib.pyplot. Inside there is a function called plot. Okay, and you pass it the data. Okay, now if the data has only one axis, like here it's a one-dimensional array, which is 1, 2, 3, 4, 5. So what does this represent? It's a straight line, right? So that's what it is plotting here. So if you provide a single list or array to the plot command, matplotlib understands it as a sequence of y values. Okay, so all this data is, so first point is here, then 2, then 3, 4, and the final point is here 5. Okay, so matplotlib assumes when you pass a single array or a one-dimensional array that it's a y value which you are providing, and it generates the x values for you. Okay, and since everything in Python starts with 0 index, was there any question? Oh, okay, sorry. Now since Python range starts with 0, the default value is always 0, and then it automatically generates values to match. So they were 1, 2, 3, 4, 5 values, so it's generated from 0 to 4. Okay, so x data was 0, 1, 2, 3, 4. So x was already generated by matplotlib automatically. So this is the most simplest plot, which is you have set of y values and you want to plot it to see what kind of function it is, like it's a straight line or it's a, I don't know, increasing function or decreasing function. So if you have just the y values, you don't know the x values, you should plot it. Generally you don't have such kind of data. You will always has x and y both, because just knowing the y values without the x values doesn't make much of sense. Okay. So easy. See here, now we change the x y values from 1, 2, 3, 4, 5 to 100, 150, 200, 250, 300. Still x-axis which is generated is from 0 to 4. So if I increase it to 350, x values are from 0 to 5. Okay, so this is the most simple one, but again nobody uses it because you always has your y-axis and you also get your x-axis. Okay, you generally don't have just y-axis data and you don't plot it. Any use case anybody knows where they have only y data and no x data? First of all, everybody understand the concept of y-axis and x-axis, I assume. Like it's basic uh, plotting. So when you plot in 2 dimensions, this is y-axis, this is x-axis. Is this clear to everyone? So when you plot in 2D, MS Paint, so this is your, so everybody remembers this, right? So this is X, and this is Y. Okay, this is positive Y, positive X, this is negative X, negative Y. So everybody remembers this, the 2-dimensional. Okay. So when you provide just one single array, Matplotlib assumes you are providing Y and it generates the x-axis automatically. So is this clear? This part we saw just here. Okay. Now, as I said, even I can't think of any example in real life where you just have Y data and you have to plot it. Okay. So obviously, what is more interesting is plot X and Y axis both. So you have both X axis given and Y axis given. Okay. So let me just show you the first version. Here. So suppose this is your x-axis, which is, so let's call it X and let's call it Y. Okay. So that, okay. So when you have both X and Y given, then this is the format in which you provide it. So first you give the x-axis and then you give the y-axis. In this example, our x-axis is data ranging from 1 to 6. 0 to 5. 0. So if you print x is values from 0 to 5 and your y is n square for n in data, which is square of the values here. So square of 0 is 0, square of 1 is 1, square of 2 is 4. So this is x and y. So it's a square function. That's what you are plotting. Okay, you see. So this is if you want to plot x and y. Remember, always first is x and then second parameter is y. So when you provide two single arrays to Matplotlib, it assumes first is x and the second one is y. Okay. Now you could also change the line style. Okay, so this the way it is plotted is called line style. So the default it is it's a continuous line which is being plotted, right? So you can change this line style. So instead of suppose this straight line like this, you want to plot it with triangles like this on either endpoints. Okay. So this is a line style. Now here if you go, yeah, here is a list of all the different line style which is possible. So this is a solid line style. This is the default. If you don't anything, this is what is used. Okay. So this this is the default, the solid line style. If you give double, this is dashed. Okay, so here is a list of all the line stand which are there. Okay, so changing this, how your line should represent, is called the setting up the line style. Okay, and that you can do using the third parameter in your plot. So you give x-axis, y-axis, and the line style. Clear? Simple enough. Like for, there was dotted line is Conan. So if you give this, it's dotted line. Okay. What else you can? So what else you want to do with this line? So when you draw a plot, what are the things you usually do? So suppose an Excel sheet. You have X and Y. Everybody have used Excel sheet, I assume. So what is the next thing you do after you do X and Y? What are the other parameters of the graph which you want to alter? Hello. Rows and values. Okay. What else? Giving color, name of X and Y and agents. Yes. So let's see one by one all of these, how to set it up for this graph in Matplotlib. Okay. So first we'll start with, so for this 9, so you can change the style of this 9, right? You want dotted lines or you want solid lines. Heading to the graphs, yes. Marking the points, okay. So we'll see all of these features, how to do using Matplotlib. So the next is, okay, so you provided X and Y, you could decide how to change the style. The next thing is, if you want to give color, so instead of blue color, you want some other color. So let me rename it back to data and data square, otherwise I have to keep changing everywhere. Now here, in this style parameter, you are saying it's green color and it's dashed line. So G is for green. Okay. So if you run this, it gives green. If you want red, you say R. Okay. So this is the second small feature, which is specifying the color. If you want yellow, I think it's Y. Okay. If you want black, what would be the for black? Any guesses? What if I want this line in black? Okay, Akash. You googled or you knew already? Okay, so if you give B, it's blue. Okay, it's not black. So for black, it's K. Okay. I already did assignment also. Way ahead. Good. Okay. So this is a bit difference. So black is from K. M. I think it's magenta. Okay, so there are different colors. Again, somewhere here, I think there is a list of different colors also, like which what is for what color. So you can get a list of all the letters and the corresponding map up to the colors also. Okay. Now, so we did line styling. That okay, this is what type of line you want. So if you want solid line, if you want dotted line, okay. Now, next thing is you want to specify the axis. Okay. So by default, when you plot using matplotlib, your x-axis and y-axis limits. Okay, so this is called limit, right? Like what is the maximum limit of your x and y? So this is your y max, this is your x max. So these values are taken from your data directly, because in your data the x is maximum 5 and y is maximum 25. That's what it is used. So max of x value is x max and max of y value is your y max. This is the default. But sometimes you don't like such graphs, right? Because see, it's almost touching the end of the graph and doesn't look very nice. So you can change your x and y axes. And now to change the axis, you use pnt.axis and you pass it an array, okay, which is the first argument of this array is x min, the second is x max, y min, and y max. Okay. So in this case, I'm saying Conan, where this is nothing. So let me show you the difference. Okay, very good point. Yes, let's see it here. You see this extra line which is coming. If you don't want this, you give a colon. Okay, so what it's doing is just part of the magic function. Just remove this extra 9. So actually this graph which you are plotting is an object, right? So now because you have said this line that okay, matplotlib in 9, you don't have to actually do pnt.show. Where am I? Yeah. So otherwise you have to do this. Okay. Generally, if you don't use the magic function, you have to always after plot have to say pnt.show. So it will show on the graph which you have just plotted. Okay. And when you do this, only the graph comes and this line which was coming before doesn't come. But if you do inline, you don't have to do show every time. You just say plot, it plots. But the problem is this plot is what? It's a this object. So it's printing the. So if you remember in Python when we print the last, only the last line is printed, right? So the last line in this cell is this object pnt.plot. So it's just printing the string version of this object. Okay, and because matplotlib inline magic function has been set, it's also plotting it inline. Okay, now if you don't want this ugly looking line to come, you say colon. Okay, this is just like a hack around to avoid this ugly looking line which comes. Okay. Yeah, so here we were showing x-axis, min-axis. Okay, what happened? Data square. Why this is not plotting? Just a second. Ah, because my x values are from 100 to 150. Why? Ah, I didn't run this code again. Yeah, now data is from here. Yeah, so see, minimum is 0 0, so it starts from 0 0. X max is 8, so your chart area has become large, and this is the graph. Okay, so this is axis, right? Y axis, x axis. So you can control the minimum, like, so if you say -1, so you start from -1. Okay, and -1. For this to make sense, you can start like this also. You can have different values. So you can say the graph axis starts from -1, -10, and goes 10, 8, and 30, and this is the plot. So you can control your x min, x max, y min, y max, so this and this, using this axis command, pnt.axis, and if you pass this array, the first argument is x min, then x max, y min, y max. Okay, we'll see another way also of doing it, like if you want to just do x or y, but this is a simple one when you want to do both x and y. So is this clear now, Sita? Everyone? Any questions till now? Anyone? So visualization is actually a very easy topic, huh? So there are not many complicated concepts here right now. There will be some when we do multiple plots, but in all it's quite easy concept to understand. You have to just know the, uh, if I don't want output, I don't understand the question, Askajan, sorry. If you don't want this 9, so this is nothing to do with Matplotlib, huh? It's a hack in notebook. So generally whatever is the last line in your notebook is printed by default. You don't have to say print. But if you put a semicolon, that object or that output would not be printed. Any other question? Okay, now then let's do a quick give me a code to plot uh, in dotted lines in red x values ranging from 1 to 20. Okay. Okay, the x value ranging from 0 to 5 as we did now, like 0 to 6, 0, 1, 2, 3, 4, 5. And instead of x square, I want x cube, okay, in red, blue, in red dotted line. So this is square, right? Square of x values. I want cube of x values plotted in red dotted lines. So if you see data and data square, these are the two arrays we have, right? 0, 1, 2, 3, 4, 5, and data square is square of data. So 0, 1, 4, 9, 16, 25. I want you to plot data in data cube. So this should be 0, 1, 8, 27, 64, 125. And then plot it using. Perfect. Very good, Akash. Ansu, you're doing n square, not n cube. I said n cube. Perfect. So Pragati gave the exactly correct answer which I asked for, which is dotted lines. So this is here. Okay, good. So everybody understood? If you do NP range 5, should we, then there's a problem, because the values are generated from 0 to 4 only. A range is up to the number you specify starting from 0. So if you give NP range 5, it will generate 0, 1, 2, 3, 4. Okay. Okay. So now, what is the other things we do? So generally your graph doesn't have only one line, right? So graph looks sexy when it has multiple lines in it. So let's see how to do multiple lines in the same plot. Simple one, using this example. Yes, Sipan, correct answer. So now let's move to the second topic of having multiple lines. Okay. So what we are doing here is we are generating a t value which is from 0 to 5 incremented by 0.2. Okay. We are plotting x-axis, y-axis, line type, line style, another x-axis, another y-axis, line style, another x-axis, another y-axis, and line style. Okay, so if you give it like this, it's plotting all the three lines into the same plot. The first one is simple, x and y is same, so it's a simple straight line. x and y is actually square of x, x and cube of x. Okay, so straight line, square, cube. If I don't give this comma here, you will see these three objects. What is BS? B is for blue, S is for square. So this squares. So if you go here, square marker. Okay. So you don't want these ugly looking lines coming up. So you have colon here. So is it clear? This thing here 0.2. Here because I wanted to generate values in decimals, right? I think it will work without this also. Let's see. It should work. But if I give decimal, then my values would be notes. It's not 0.5, 5.0. Okay. Can you try to change? Wait a second. The value of x-axis in any one of the plots like t-square or any other. Okay. Let's create another t range. X new. You can do that, huh? That's not a problem. Let's do it 10. And y is equal to, let's do this, x new, x new. So this one is your 1 9, this is square, this is cube. Okay. Yes, if you remember the formula for parabola. But one thing remember, okay, if you give here t, this would accompany it. Okay. Because your x and y should be first dimension. Should have the same, because here our x values is from 0 to 9 and y is only for 0, 1, 2, 3, 4. So it doesn't find y values for remaining x values, so it's accompanying. So as many values you have in x, you should have corresponding y values. Okay. And what you say, y is equal to 4ax. What is a? Is the constant. So you could have 4 times a, let's clear it, 10. Okay. So it's 40 times x new. But are you sure it's 4ax? Because it's a straight line, huh? See then. Anyway, I don't think that's the correct parabola equation. Anyway, questions? So plotting the square function is parabola. Okay, I thought it's a different kind of growth function. Because here you're just plotting the square from negative to positive. This is positive square, this is negative square. Y square is equal to 4ax. So let's do this. 40 times x and this would be, I don't know, y square. I know, but then y is 2 root ax, right? I don't know how to plot root values. But of course, when your data would be in this, this would turn out to be y is equal to 2 root ax, then you generate these values and it should work. Okay. But data generation is independent, so it doesn't matter. Whatever data you have, whatever characteristic it has, it will show it when you plot it. Okay, that's the beauty of plot. So suppose you have a long x and y values, you don't know if it is straight line or if it is square or if it is cube or it is what. You plot it and you get an understanding. That's why the visualization is helpful. Okay. Any other question apart from different kinds of data which we could generate? Everything clear till now? Okay. Now, so other properties of line which we could control. First one is, so we saw how to control line kernel, right? You can control line width also, and you have to say, okay, pnt.plot data line width is equal to 5.0. Let's take this example. T T mhm, is equal to 5. Okay, so to see the difference, so this is 9 plot 5, or if you make it 2, so you can control the width of this line, and the property to set is line width. Okay, now the other things which people were saying, like somebody mentioned neighbors, right? Who mentioned neighbor? Name of x and y and legends. So first, before legend, let's do labels and the heading to the graph. So that is called title. Okay. So name of x and y are called actually x and y neighbors in graph, and heading to the graph is called the title. So Ansu was mentioning heading to the graph, which is actually called the title of the graph, and name of x and y axis is called setting up the labels of x and y. Okay. How you can do that? It's very simple. You say pnt.plot is same, and you set pnt.title, the title of the graph, pnt.xlabel, the label of the graph, x, y label, y label. Okay, and this is this. Questions? Very easy. So now we have y-axis. So this is what you meant, right? Name of x and y. Okay. So now the graph looks something which could be shown. It looks nice, right? It has x neighbor, y neighbors, and all. And what is the next thing? So grid lines. Okay. Now sometimes when you are plotting, you don't know, okay, if this point is 40 or not, it's before 40. So suppose this point, huh? Now to find out, okay, if this point is before 40 or on 40, before 1500 on 2000, what is the things you do? Okay, you want something called grid lines. Okay, so if you say pnt.grid true, it creates this grid lines for you, which helps you know exactly where your points are. So this is like a helpful feature sometimes when you want to know, okay, if this point is, okay, this point is before 40, before 40. This is between 40 and 150, 170. Okay, this is more than 40 but less than 1750. Okay, so these are called grid lines, and this is useful to read the graph. Now to set grid lines, you say pnt.grid true. Okay, simple enough. Now another thing was somebody mentioned marking. Who mentioned marking? Mm, marking the points. Okay, so there's something called annotate. Okay, so sometimes specific areas in the graph you want to annotate. So it's not equivalent to marking that each point is shown. Yes, different. But suppose you have a graph, okay, and at some specific point you want to mention some annotation, like you want to annotate something. So you can say pnt.annotate, pass the message which you want to put, and the position where you want to put this message. Okay, so you say xy is equal to 4, 16. So what is this xy? This is the xy coordinate. So it's at 4, 16. This message has been printed. Okay, so this is called annotation. Okay, again my data and data square has changed. That's why this problem. Data square. Okay. Wait. Okay, let's change this. Square of 3 is at 3, comma 9. Yeah. How can we highlight the marked points, like each specific points? You want the values there? You want the values or you want to just highlight? What kind of marking? So we can do it using one of the existing thing we have seen. Anyone? How can we do it using the existing features we have seen? No. So using the existing features, how can we draw a line graph with the specific points marked as a red triangle? Let's see who can do that. So I've paused my screen because I have the answer. Okay, let me remove my answer just a bit and let's see what people are answering. Okay, so Akash is saying data square RO. No, but if you do this, your line is gone. I want the line also. So I want the plot as this line and these specific points to be marked as triangle or dot. Grid now. What else? Painted. Perfect. Akash. Good. Not neighbors. Yes, Pragati. Two lines, one with row, one with continuous line. So you plot it again. One with red line, one with blue. And this was Akash answer also. I wanted triangles, so triangles. Okay. Is this clear? So it's two lines, just the same data plotting, one with lines, another times with points, markers. Okay. Very good, Akash. So is this clear to everyone? Okay. Now, I mentioned earlier also that x limit and y limit, one way to set it was passing this array to axis. But if you want to just set, suppose one of the axes, you can use limit. Okay, so if you want to just set, suppose x-axis and not leave the y-axis as it is, you say pnt.x limit and pass it a. So this is array of x mean, x max, and this is array of y mean, y max. Okay, so setting up x limits or y limits individually. Okay. Next things. So these are simple graph properties. Okay, so I think it's all clear. If I'm going fast, just ask me. Okay. Next property, ticks. So you know what are ticks, x ticks and y ticks. So you see these ticks marks. So when I say x limit from 0 to 10, it divides it into different ticks, right? So after 0, then 2, then 4, then 6, then 8, then 10. So these are called x ticks. And this is 0, 2, 4, 6. These are y ticks. Okay. Now sometimes you may want to change the default behavior of these ticks. You may want more ticks. Okay, so you want 0, 1, 2, 3, 4, 5, all of these ticks. Okay, so these could be set using a property of plot called x ticks, and it takes an array, and y ticks, which also takes an array. Okay, so if you plot this, so these are like overlapping, but y-axis is more clear, right? So instead of, so you have 0, 0, 2.5, 5, 7.5, 10, 10.5, like this. 0, once here you have 0, then you have 0.25, then 1, 1.25, but they are overlapping. But these are the x ticks you have generated. Okay, clear? This ticks, the ticks is just this markings which you want to generate. If you not have given it, default would be this. Okay, but if you want, you can specify y tick, and you can specify x tick also. Okay, questions? Hello, questions till now? No, nobody's bothered that this is overlapping. It doesn't look nice, right? So if you give a graph like this to your manager, he will shout at you that what the hell is this? So what should you do to make it readable? Any suggestions? So I want to keep these ticks, but I want them to be readable. What could be done? Okay, Akash. So Akash, you should answer me in private now because you have done it already. So I think it's not fair that you answer so fast, but it's correct answer. So rotation. So if you would have worked in Excel sheet instead of, so right now it's coming horizontally, right? So you could rotate the X labels. Okay. So X ticks, you can say rotation, and provide a degree by which you want to rotate it. Okay, so now your x values are rotated like this. So earlier it was horizontal, now it's rotated like this. If you pass it here 90, oops, sorry, it's 90-degree rotated. Okay, no problem, Akash. We can't increase the width, but the width is fixed, right? Because this is 0 to 0 to 0.5. You mean the width of the whole graph, like make it bigger and then these fonts are smaller than it's visible? Yes, that could be done. We see an example of that also then later. 2.5 is not the width. This is NP range. So here, so white ticks we are passing the values of the ticks. So this is an array. So this is an array. So we have seen it multiple times. So this gives me an array from 0 to 5.25 with an increment of 2.5. So it's giving me this array 0, 0.25, 0.5, so 7, this value. It's not the width. It's just an array from 0 to 5.25 incremented by 0.25. If you make it 0.35, then it will increment it by 0.35. That's all. So you're changing the x tick values itself. Okay. So of course, if you decrease the number of ticks, it will be more readable. But if you want to keep the same number of ticks, then you rotate if it is overlapping. Okay. And generally 40 is a good rotation. Okay. Tick rotation. Now the next property is called splines or SP9s. So let's take an example and then it will be more clear. So let's plot square and cube from positive to negative. So from -5 to 6, values square and cube. So this is square, which is always positive, and this is the cube, which is negative for negative and positive for positive. Okay. Now you see this x-axis and y-axis always start from 0, 0. So these lines, okay, these lines are called splines of the graph. Okay, and you can control them also. So what you say, so this is now a bit different concepts, so bear with me. So when you say pnt.plot, it's plotting this data, right? So x-axis, y-axis, x-axis, y-axis, right? This is what we did here, pnt.plot the data. Now this is actually what, it's an object in Python, right? It's creating a plot object, and because of the inline matplotlib function, it's plotting it also as a visual representation for you. But for Python, it's an object of plot kind, right? So this object has different attributes and you can access those attributes. Okay. So one of the attribute is GCA, okay, which is, it's a function which is asking it to give you the current axis. Okay. So these are the axes of the graph, right? And these lines are called splines. So using pnt.gca, what you are doing is you are getting an axis. So access to the axis. Okay. Access to the axis. Okay, so let's take this example. per Excel sheet. So you have 1, 2, like this. This is going to 1. Square. Suppose this is your X and Y, and when you plot it in Excel sheet, insert line chart, suppose, okay, 2 lines. So this is your plot, right? I haven't explained it. First, you understand what is a plot. So this is a visual representation of the graph. But for Excel sheet, this is a plot object. So if you double click it, it opens different properties of the graph which you can set, right? So you can set this, you can set the axis. Okay, so there are different things we could set. Okay, so this is what an object means. So this plot object has many properties which you can set, right? Now in Matplotlib, okay, till now we saw, okay, you can set xticks, which is a property of the graph. Now when you do pnt.gca, it gives you access to the axis object of the graph. Okay, and then you can, so this axis object, so this is different than when I click here, you see, because this is like chart area and this is different kind of properties which are coming, right? Because this is axis object. So depending on where you click, you get different options in Excel sheet, right? Similarly, because you want to edit that property of the graph. Similarly, because here we wanted to edit the axes of the graphs, which are splines. So these are actually called, this line is spline. Okay, and what I want to do is I want to edit. So this is the final output I want. Okay. So how to do this? So that's what we are trying to do. So first thing you do is you get an access to the axis of the graph, and then you say axis dot this ax dot spline right. So right is this. So this is right, top, left, bottom. These are the 4 splines of the graph, right? I'm saying axis dot spline right, set color none, axis dot spline top, set color none, axis. So let's just do this 2 first. Let's do it one by one. See, axis dot spline right, set color none. So this is gone. Then I say axis dot spline set top, set color none. So these 2 spines are removed. Now I say axis dot spine bottom, set position. So I'm moving it from here bottom to data 0. Okay, which is saying that to the input data 0, whatever is the 0 for the data. Okay, then axis dot left, set position data 0, and this will move it to here. Okay, now this graph is better or this graph is better from visual point of view? Other one, right? So sometimes when your data points are going to negative axes, like on the 4 quadrants, you might want to change these splines, and for that you have to get access to the splines using the axis. So these are called splines. Is it clear, Sitan? What are splines? These lines, these in graph in Matplotlib are called splines. and its property you can set. You can access them individually by right, left, top, bottom, and then set its color, set its position, etc., etc. Okay. All good. Now next is legend. So I think this was one of the last properties which somebody mentioned. So what is legend? That okay, you have this orange line and blue line, but in the graph sometimes you have this, right? That orange is this, orange is cube and blue is square. If you are giving set color as none, then how it is taking color? Spine is invisible, so there is no color. We are setting color of the spine, and this is the color of the line. Now the good thing about matplotlib is that when you plot multiple lines, matplotlib will give different color to each line. If you don't specify specific colors, each line will have a different color. So these are line colors, and this is spine we are setting. Okay, we are setting color of spine. We are saying right spine set color none, so it's become invisible. For top spine we say set color none, so that's why the top became invisible. Okay. Any other question? Question so far? Yes, no? Unclear? Okay. So I was saying next property which somebody mentioned was legends, right? That okay, you want to draw here. Orange is square, orange is cube, and blue is square, right? So for legends, what you say, pnt.plot, data square, label is square, data cube, label is cube. Okay. Now this, let me so without legends also this would work. So you could say this also, data square, pnt.plot, data cube. Okay. So this and this is equivalent. So first you plotted this and then you are plotting this. So it's same as plotting multiple lines. Okay. So that's what we are doing. We are plotting multiple lines. First this line and then this line. And with the line we are also giving a label. We are saying here the label is square and here the label is cube. And then this is what we saw just now, and then you say pnt.legend. Okay. And then the label which you have provided to the data in the plot will come here. So here if you say Rohit, the label will come as Rohit. Okay, you have to say pnt.legend. If you don't do this, legends will not come. Okay, so you have to say pnt.legend. Just providing the neighbor is not enough. Okay, now if you don't provide this and say, then only one of the neighbors will come. If you don't provide any neighbor and just say plot legend, then none of the neighbors are there, so nothing will come. Okay, so both is important. You have to provide the neighbor and neighbor is going to cube and pnt.legend. Okay, so any questions so far? Yes, we'll take a break now. So till now we saw different properties of graph, how to set it. We saw how to set line styles, line width, x-axis, neighbors, legends, titans. So all these things we have seen, right? But nothing complicated. It just you should know how to do it. So any questions? If not, let's take a break. Let's meet in 10 minutes. So I think it's 11:30. Let's meet at 11:40. Okay? Just go through it. Okay, you should have access to this notebook from training site. So if you want, you can go through it again, and if you have any questions, ask me after the break. Okay, everyone? Okay, then I'm going on break. Let's meet at in 10 minutes. Hello everyone. So please message me here when you are back. Okay, so let's start. So I think more than half of you are back, so let's start. Just let me check. Akash, you're back. So I have Akash Agarwal and Akash. Ansu, SK Jain is back. Pragati is back. Supratik is back. Himanshu, Seetan is back. Supratik is back. Okay, let's start. So till now we saw one figure only, right? In one figure having multiple lines. What we saw, and we saw how to control its properties and everything. Now the next topic which we are seeing today is working with multiple figures and axes. Okay, and this is also quite common that you have multiple plots done. So for example, this one. Okay, so this is two graphs side by side. So we'll see how to do that. So multiple figures. Now for this, what we use is something called subplot. A subplot creates a figure and a set of plots or subplots as we call it. So it's a utility wrapper. Okay, which so we had plot, right? Subplot is a utility wrapper which makes it easier to create common layouts of the subplots, like uh, where to place it and etc. We'll see them one by one. Okay, so let's take an example again. So we have suppose x-axis, which is uh, equally spaced value between 0 to 2 times n pi with 400 points. Okay, so this everybody could understand. What is 9 space? I think you guys remember. So it's generating 400 equally spaced point between 0 to 2 times of pi. Okay. And y value is your sine value of x square. Okay, so these are x and y values. Again, how you generate data is not very important in this class. So if you're having confusion on x and y, don't worry. So what you have is x values, which is from 0 to 2 times pi, 400 equally spaced values, and y is the sine of the square of the x. Okay. Now what we are using is subplots. So subplots give you two things. It gives you a figure object and it gives you an axis object. Okay. And we use the axis object to plot. So for a single figure axis is simple. So you say figure comma axis is going to pnt.subplots. You don't pass any parameters here. And then you say axis dot plot the value xy, and let's set title. So all these properties which we saw before, we work with this axis. Okay. And this is the output. Okay. Okay. But this is not interesting. What is interesting is having two plots like this. So you say subplots 1 comma 2. Now what this is 1 comma 2 means, one is number of, so first is number of rows and number of columns. So if you say pnt.subplot 1 comma 2, it will divide. So this is your graph, the whole figure area, right? So this is your whole figure area. So when you don't pass any parameter, it gives you only one plot out of it. But you can create multiple plots. So for this example, I'm creating two subplots, which has one row and two columns. So it gives me two axes, axis 1 and axis 2. Okay, these names are variable names, so you can call it anything. You can call it A1, A2 also. Okay, so the name is not important because these are variable names. Here we are calling them axis 1 and axis 2. Okay, then on the first axis, which is this first subplot, you would plot x and y, set title. In second axis, again you plot x and y and set title. Okay. So this two area division is clear. This 9 style is automatically changed by Matplotlib, so don't worry about that. You can control it. Obviously, you can specify which kind of style you want. But important thing is to understand this subplot. So you are dividing this figure, the whole graph area, figure area, into two subplots like this. You say subplots 1 comma 2, that is in one row divided into two columns. Then you access each subplot individually and plot the data points. Okay. Now if I wanted top and bottom, then what should I do instead of side by side? So if you give 2 comma 1, then it divides the whole figure area into a subplot of 2 rows and 1 column. Okay, so that's why it's top and bottom. Okay, so this is how you plot multiple figures in the same plot using subplots, and you can control the position, how many plots to have, all this thing using these parameters. So there are different variations of this. So You can have 4 plots. You can say pnt dot subplot 2 comma 2. So now it's dividing the figure into 4 subplots with 2 rows and 2 columns. And here we were taking this as a variable like this, axis1, axis2. But if you have a single variable, suppose axis, then what you get is 0 0 would be the first, 0 1 would be the second. So this is 0 0 0 1 1 0 1 1. Okay, in this case, if it was axis like this, so if it was one variable, then this would be axis 0 0, and this would be 1 0 1 0. Okay, so 0 0 0 1 1 0 1 1, and obviously you can have it here like this: a1, a2, a3, a4, and then you can say a1, a2, 3, 4. Okay. Mm, wait. Ah, and if you want to give it in 4, you have to give it like this: a1, it's a square, a1, a2, a3, a4. Okay, like this. A2, a3, a4. Okay, first row 0 0 0 1 1 0 1 1. Okay, so you can either have them as individual variables or you can have them as axis. So is this subplot clear? Yes. So questions on the subplot. Okay, everybody is very silent. Subplot is doing nothing, it's just dividing this figure into different subplots depending on how many. So think of it as a grid area, like this is your whole area. It will divide it into different areas. Like if you say, so like, no, this is not a good example. So if you say 1 comma 2, it will create this. If you say 1 comma 2 comma 2, it will create this kind of like 4 cells. Okay, so it's dividing the given figure into different subplots based on how you want to divide it. Okay, and then you can access each subplot individually and plot on that subplot. Now suppose if you don't plot A3, then this would be empty. So only 1, 2, and 4 is plotted, and this remains an empty subplot. So figure is the whole figure. So this is one figure. So sometimes you could set like a title of the figure maybe. Okay, so we'll see what attributes figure has. So each individual subplots are here, and the whole figure attributes you can access using the figure object. Okay. I think it would be more easy to see like this. So access, let's like this, and so when you do figure access pnt.subplots 2 comma 2, it actually create these 4 empty subplots. If you say 3 comma 2, it will create these. If you say 2 comma 3, it will create these many subplots. Okay, and then now if I want to plot something here, what should be the value of this access array I should access? It's overlapping because the figure is the same. So this is the figure, huh? So this is the size of the figure which you have, the plotting area. So one figure has this much plotting area only. This is the area in which it could plot. Okay. Now if you make something smaller, bigger, it will adjust in the same area. Okay.
That's correct.
Okay, somebody is speaking. I have to mute everyone. Now my question is, if I want to plot something only in this subplot, how should I access it? Yes, giving out of access, right? Akash, yes. Good, Akash. Not access 1, access 2. No. That's the difference. That's what my question was. So now this is an array. So subplots gives you an array of the subplots. Now if you map that array to an array of variables, then each variable you can access individually. Or if this is an array variable, you can access area. So 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2. Okay, so if you want 1, 2, it will go to the last subplot. Okay. If you wanted individual values, then you have to create it as an array. So you have to say it's 2 comma 3, so it will be a1 comma a2, then again a3 comma a4. No, it's 2 comma 3, so it will be a1 a2 a3 a4 a5 a6, like this. So then this would be a1 a2 a3 a4 a5 a6. Okay, but you generally then use like one variable like a, and then you can access simply with the array. Okay, is it clear? Yes, no? This is very important to understand, because once you understand how to access these plots, then manipulating is easy. But you should understand how we are accessing them. So is this clear to everyone? Please, if not, just ask. Yes, no? Not much clear. Which part? So accessing the graphs. Okay, forget about these individual variables. Honest, so by default, this is what everybody uses. So when you do pnt dot subplots 2 comma 3, so think of it as, so what it is doing is dividing this whole figure area into 2 rows and 3 columns. Okay, if I say 2 comma 2, it will divide into 2 rows, 2 columns. So row 1, row 2, 2 columns. If I say 2 comma 1, it's 2 rows, 1 comma, 1 rows, 2 column. Okay, this is easy how to divide the plot. Now these plots could be accessed using this second variable here as an array. Okay, so think of it as an array. So this is an array, right? This is the first 0 0 array, this is 0 1. So that's fine. Let's take this example. If you divide into 2 comma 2, this is 0 0, this is 0 1, 1 0 1 1. Okay, if you divide into 3, 0 0 0 1 0 2, 1 0 1 1 1 2. Okay, if it is 3 3, then what is this? On 3 by 3 array, what is this? Yes, because the subplot is an array. So what is this? 1 1. What is this? 2 1. What is this? Ansu? 1 2. Okay, so now is it clear? So using subplots, you divide into different plots and then you can access it by the array index of that plot. Okay, moving on. Now, some things you could do is, so when you plot, like see here, it's a row overlapping and it's the same index neighbors which are getting copied everywhere, right? So sometimes you want to share the axis. So you can say share x-axis with each column of the subplot. So you say pnt dot subplot 2 comma 2. So you create 2 subplots. Let's do one without, and then so this is your okay. So here you are dividing the subplot into 4, but see each subplot has their x-axis and y-axis, right? Now if you say share plot share x, so you are saying these subplots will share the x column, okay, x axis, and it take either true or false. So So if you say share x column, so they are different values. Huh? So let me give you this. So this share x takes either a boolean whether they are sharing or not, or it takes values like none. This is the default. That okay, they don't share x, or all of them share x, or the column ones share x, or the row share x. Okay, so now when you say true, so when you say true, or you say in brackets all, this means x and y will be depending on if it is share x or share y. So for share x, it will be x will be shared among all subplots. Okay. If you say false or you say none, which is default, it means x is not shared. Okay. So what is mean by shared? So let's take an example of column or say all. So only x-axis is coming here. Okay, and we say column. Row. No, maybe for 2 by 2 it's not very. Yeah. So when you say share x column, so for these column, x-axis is okay. These column, the x-axis is shared. So see, this x is not coming. If you say y, then row will not make sense. Column will not make sense. Row will make sense. So say this share y. So these on the plots in y in the row is sharing the same y. Okay. And you can say share x is cut to column. So this is the same y for this whole row, same y for the whole row, and same x for the whole column, same x for the whole column, same x for the whole column. Okay, so this is what share x and share y are. So on the subplots, you can share the axes. So then it will not plot the axis again. Okay. Obviously, if you say column here, then it doesn't make much sense. So share y with row and share x with column. This is what generally people do. Okay, so share y with row and share x with column. And when you say share x all, share y all, it's equivalent to okay this one which we just saw. Okay, so what we are doing here, we are sharing the axis. We are not repeating the same axis again and again. So here, so what happens is, so when a subplot share an axis, suppose when subplots have shared x-axis along a column, then only the x-ticks neighbors, these neighbors of the bottom subplots are created. And when you say share y-axis along the row, then only the neighbors of first columns are plotted. So that's what is happening when share x and share y. Okay. Clear? Now, what if you want to plot something like two graphs here and then one chart like this? So instead of two here, you want two here and then only one chart here. So that's my next requirement. So nobody asked me, but suppose instead of two and then one empty here and then only one here, I want two here and then one here. Okay, so you can do that also using subplot, and that's what we'll see next. So now the first example we saw of subplot was using this rows. Now this is another way of using subplot. So you say subplot and you provide it a number. Okay, what this number is, it's the number of rows, number of columns, and figure number. They are not comma separated. Okay, so the maximum you can go is 999. So 9 ninja 81, but nobody goes up to here. So it's 1 2 2 2 1. So you say two rows, two columns, number of figures is 4, right? Here you say two rows, one column, number of figures is, so figure number 1. Okay, so figure number, let's plot this one by one. So what you see, this graph is coming small, right? Now if I plot these two, it's coming one after another. So what it is doing is dividing the subplot. So when you actually say subplot 2 1 1, it divides the plot into two rows, one column, and take the first figure number. Okay, so in this case, this is the first figure, second figure, third figure, fourth figure. Okay, so 2 comma 1, figure number 1, 2 comma 1, figure number 2. If you say 2 comma 1, figure number 3, then it will give an error because there is only two figures in 2 comma 1, like 2 1. Okay, so there is no figure 3 in a plot of 2 into 1. That's why it's giving error. Now coming back to my question of how to do. Now here we said subplot of 3 rows, 1 column, figure number 1. 3 rows, 1 column, figure number 2 is this area. 3 rows, 1 figure number 3 is this area. Now if you don't plot this, now this is the beauty. This area is empty because this area is reserved for figure number 2. Okay, but because you have not actually created the plots like this, like you have not get the plot axes, it's not creating the empty axis also, just giving the empty space. Okay, so when you, so actually how it is different, so this kind of subplot is different from the previous kind of the subplotting we did, because in the previous subplot it was creating the axis, right? But when you pass subplots like this, it does not create the default axes. When you access this figure, only that figure is created. So this area is reserved, but no axis is created because there is nothing provided to it. Okay, so this is different way of one by one plotting the subfigures or subplots. So the first approach was we create empty subplots and then access this subplots to plot. This approach is you access the subplot directly without creating it. So you access the subplot directly with the row number, columns, and the figure number. Okay, so this is the main difference of plotting it one by one. So now we are plotting it, and then that's why this area is different, is empty. Okay, so if you plot now, it will come here. Okay, so is the difference between these two subplot approaches clear? So if you give comma separated values in subplots to get an axis object, in that case, which we saw before, like this, it was creating this empty subplots, and then on each empty subplot you can plot. In one by one approach, which is like this, where you give it one number for number of rows, one number for number of values, and then the figure number, it plots only on that particular area which you have mentioned. Okay, so it will also work like that. If you say 2 comma 2, 2 comma 2, figure 2, 2 comma 2, figure 3. See, figure 1, figure 2, figure 3. Figure 4 area is left. Okay, is this clear? So earlier we were creating the empty spaces, plots, and then accessing these plots. Now we are not creating the plots beforehand, but we are accessing the areas of the plot by this approach. Okay, now if I wanted this graph here and this area empty, then what I could do? So I want like this, but this green I want here, not here. Then what should my value here? 2 to 4. Okay. Now, Akash, you can also answer in public if you know. So what I want is these two graphs here as it is, but this graph I want in the whole area. So I just want this graph to be in this area. So what is this area? Who can tell me? So this area is 2 comma 2 comma 1. No. When you use comma separated values like this, it creates the plots. Okay. So what we want to do is plotting one by one. So in this approach, you give the number of rows, number of columns, and the figure number, and then subplot plots in that area. Okay. So this area was dividing the area into 2 by 2 and taking the first figure. This area is dividing into 2 by 2, taking the second figure. What is this area? Okay, so there's some answers now. So this, so Pragati got it. 2 rows, 1 column, figure number 2. 2 rows, 1 column. Figure number 2 is this area. Very good, Pragati. So is this clear? So this area is second row. So if we divide the whole chart into 2 rows, divide it into 1 column, and then the second figure is this whole area. Now if I wanted 3 small charts here and 2 charts here, okay, then how will I plot it? So here I want 3 and here I want 2. So what I want is something like this. First this 3 and then this. Something like this. Then this is what this area you can access. So what is the first? It's the first row and you want to divide into 3. So this would be 1. So you want to divide the whole graph into 2 rows, 3 columns, and you want to access the first figure. Okay. This would be 2 rows, 3 columns, second figure. This would be 2 rows, 3 columns, third figure. Okay. This is if you divide the area into 2 rows, 2 columns, first, second, third figure, right? And this would be 2 rows, 2 columns, fourth figure. Okay. So is this clear to everyone? Done? Doubt anyone? So let's do a new. So suppose this is your figure area, total area. Okay. Now you want to divide it into. So I want to divide into 2 equally spaced. Here I want 1, 2, and then I want like this. This is how I want it. Okay. So you to access this part of the chart, you say. So this is what you divided it into 2 rows, and this one you divide into 3 columns. So it's this area is actually 2, 3, and the first. Okay. This is 2, 3, second. This is 2, 3, third. Okay. This is if the whole chart would have been divided into 2 by 2, then this is 2 to third, and this is 2 to 4. So now again, let me ask and save. This is your chart area, and this. Assume they are equally spaced. Huh? Now, how will you access this area? What is this area? So this part of the area. 341. Is this clear? 341. This is clear. Now, if you wanted to have access to this area, how you should divide the graphs? Then you win access to this area. To get access to this area, this you suppose your original area. You have to divide it into 3. So if you divide your graph like this, then this is this area, right? Which is 3 by 3, and figure number 1, 2, 3, 4, 5, 6. Okay. Divide the whole area into 3 by 3. Figure number 6 is this area, right? So which is this area? How to get access to this area? If you would have the same figure, if you would have divided into 3 charts like this, and like this, then this is this area, right? So what is 3 by 2? Figure number. So this area is. So now is it getting clear a bit? So when you say subplot 3, like in this case, this should be 3, 2, figure number 6. So you're saying the area, so whatever the full area, divide into 3 by 2 and give me the portion which is for figure number 6. When you are accessing this part, you will say, okay, divide the whole area into 3 by 3, then give me access to figure number 1, 2, 3, 4, 5. Okay. So now is it getting clear? Akash? So what would be, so if I had even subdivisions here, so what would be this one? Who can tell me? What would be this one? Mhm. How are you going to create this area? 3 rows. How many number of columns to get? Why 5? If you do 5, wait, let me do it again. Control N. Sorry, Control. mm, Don't save. When you say 352, it will create 3 rows. Sorry, 3 rows and 5 columns. Again, equal space. So 382. That was the right answer. Because what I did was this area, subplot 1 to this one. Now what would be this one? Consider it equally spaced. So to get something like this, so 1, 2, 3, 4, 5, 6. Right? So if you divide it into 3, 6, yes. Okay. But generally you don't go to such high numbers. It's mostly between 2 or 3. Yeah? So you don't divide your subplots. So generally you don't have more than 2 or 3. So if you don't still able to understand, you can just remember these values. Okay, but it should be clear now. Is this clear? Very good. So with this plot dot subplot, you specify the area, and then in that plot you could plot. Now here you can do everything we did. So this one subplot on the properties we want to set could be set. Okay. Now let's move to different topic of different types of plots. So till now we saw only 9 charts, right? No. Okay. I didn't pay attention to time. We don't have much time. Anyway, next week there is not much, so let's not. So we do only 2 or 3. Okay, so before I move to different types of plot, any questions till now? Don't worry, if you want, I can repeat again if something is not clear. Is it all good? From this, you got the example, right? So, mhm. What would be this area? Just let me ask some other people who are very quiet. Himanshu, you there? Okay, I don't know if Himanshu is there. So quickly tell me, what would be this area if I have to access it? This one. Not Pragati and Supratik and Agarwal, Akash. Anybody else? Tell me in private. This area. Correct answer. Tell me in private. Others? Akash, this area, this area, this area. Pragati, good. Akash, this area. The third number is a figure number. No, Survi. This whole area. To get this whole area, you have to divide the figure into 3 rows, one column, and figure number would be, to create this area, you have to divide the graph into 3 rows, one column, and the figure number would be what? So forget about these. Huh? So let's see. Forget these. 1, 2, 3. Why people are saying 3, 1, 1? This is figure number 3, right? Why you are calling it figure number 1? Akash and Seetan. So this whole area doesn't matter how many lines I draw here. Huh? So if I draw a line here or here, it doesn't matter because this area remains same. Huh? Okay, perfect. Any other question? Surbi, is it clear to you now? Okay, very good. Others, there are some people who are very silent. I don't know if they are understanding. Supratik, okay, you understood. Srihari, Himansu, Swarda, yeah, okay. So now I'm moving to the next topic, which is different types of plots which are there. Okay. So till now we were using matplotlib.pnt, but all these functions are also inbuilt in pandas. Let's do two types today, Seetan. Like we have 20 minutes, so we'll do just two types, and then rest of the types we'll do next class. Okay. So again, pandas data frame, everybody knows. So this is the deliveries column. Okay. Now every panda data frame has something plot. Okay, this is a plot function of a data frame. Now let me do this. First I have to run this. So this data frame, or okay, in this case it's a series. So a series could be plotted, a data frame could be plotted. Okay. and they have this inbuilt function called plot. Now in case of a series, this index, even in case of data frames, the index is always the x-axis. Okay, so if you plot a data frame or if you plot a series, the index becomes the x-axis and then the values are plotted. Okay, so let's do a simple one. So here what we are doing, so this is pandas code. Everybody should know this, that okay, we are grouping by batsman, then taking the sum of the batsman run and taking the n largest top 10 values. So these are my top 10 batsmen and their run. Okay, so this is a series. So the index, so index becomes x-axis and the columns become y-axis. Okay, so whenever a data frame or series, when you plot it, the index will become the x-axis and the columns will become the y-axis. Okay, so in this case it will take this as x-axis, so it's plotting in the x-axis the index values, which are these names, and in the y-axis it's taking the value of the y column, the column which was there, the scores. Okay, now inside the plot you can set title, saying title is equal to this. Rotation, this is for rotating the x-axis labels. Now the index, so you see, if you see this again, this becomes the x-axis label. Okay, if you had, so if it was not a series but okay, let's take this instead of n largest 10, this example, let's take this example. This is again a series, index values, when you plot it as a bar, this is a bar chart. Okay, first we are starting with line charts, which is the simple charts, line plot. So if you don't give any type, default type is line chart. Okay, so this is a line chart. So what you do, just plot, title, rotation not mandatory, but okay, this is a line graph. Okay, so default plotting is line chart in pandas, even in matplotlib. Okay, now the second type is bar charts. Okay, so same data. This line chart doesn't make sense, right? Because these are string values. Same data, you say kind is equal to bar. Okay, title, and you plot. Now this is bar chart. Same data as line chart, same data as bar chart. What you did, kind is equal to bar. Rot is rotation. Rotation of the x-axis. Okay, if I don't provide rot, it will be like this. So I'm rotating it by 40 degree to make it look cooler. Okay. Now color map is for the color of this bars. So there are many color maps which are available. So there's a reference to different kinds of color maps. I'm using something called cool warm, okay, which gives me this color. Okay, and there are different color references. So to do a bar chart, you say kind is equal to bar, or you say plot dot bar. Okay, so these are equivalent. So either inside plot you say kind is equal to bar, or you say plot dot bar, and then all other parameters. Okay. So instead of this, if you don't want to provide kind, you say dot bar. It's the same thing. Okay. We are not using pnt.plot. So in pnt.plot, you have to pass data like this, right? pnt.plot data. This is the plot function for the data frame. So each data frame, so that's what I mentioned here. For data frames and series, there is a inbuilt plot function, okay, which is same as the matplotlib plot, and where the x-axis is always the index and y-axis is the columns. Okay. So every data frame in pandas and series has this inbuilt function called plot, which internally actually calls pnt.plot. So this is what happens internally. So if you go inside the code of Python library in pandas, what they do is when you say data frames.plot, they pass the index values as the x axis and the y columns as the y axis. Okay. So that's what internally it is doing. But to make it easier for you to use, that's why they built all these functions. So you don't have to get the x-axis, y-axis, parts it to pnt.plot. Okay. Default was line chart, and you can do bar by saying kind is equal to bar, or you say dot bar. Both are same. Okay. So let's suppose you have this data frame which is 3 columns or 4 columns A, B, C, D. When I say df dot plot, wait, let me do this in the other one. The index 0, 1, 2, 3, 4, 9, that became the x-axis, and the 4 columns, they became the y values. Okay. If I just say dot plot, then this will be line chart. So 1 9 for each column. Okay, if you say dot bar, then 1 bar for each column. So blue is A column, this is B column, C column, D column. Okay. Is this clear? So x-axis is your index, y-axis values are your columns, A, B, C, D. It will be more clear in line chart first, right? A, B, C, D, the columns. Simple. If you say here kind is equal to bar, then it will become bar chart. Okay, and color map is how you decide the color of the bars. If you don't give a color map, it will use the default ones, which are these blue, orange, green, red. Okay, questions? The main thing to remember here is this point, that for data frame series and series, there's the inbuilt function plot, which takes index as the x-axis and the columns become the y-axis. Okay, questions? Now there's a stacked bar, but let's do it next time. I don't want to confuse you guys. Then we see pie chart, histograms, box chart, and area chart, and scatter plot. So there are like 4 or 5 different kinds of charts. But once you understand how the data works, then understanding different types is easy. There's always an index in data frame. So you cannot have a data frame without index, because every data frame has this default index, right? Which is 0 indexed. You cannot have a data frame without index, because if you don't provide any index, it will create the index starting from 0 in the number of rows. Questions? So we saw line chart and bar chart. Next week we'll see different types of, so stacked bar chart. Okay, then pie chart, histogram, box plot, area plot, and scatter chart. These are some other charts we'll see next time. These are easy to understand once you know how the data is being processed, is shown in the chart. Index is x-axis, y-axis is your columns. So we'll stop here. If any question. Questions, guys? So everything clear till now? Before I forget and you guys start leaving, share feedback. So today we actually covered most of the important concepts on plotting. Okay. Next week we'll see on these individual types of plots like histogram plot and their properties, then pie chart, box plot, etc. And in which case, which kind of plot is more important. Okay, like what kind of data you have, and then which kind of plot you should do if you have that kind of data. Sorry. So that we'll see in the next class, and we also will see C-bond, which is a cooler version. So C-bond charts looks much nicer like this. See, so a bar chart in C-board looks much cooler than a matplotlib. So we'll see this in next class. Okay. So if no questions, we can end. Have a good Sunday. Again, any questions, guys? If not, you can go by after providing feedbacks, please. And we will see you next week. Okay, then, guys, see you next week. And the recording for the extra session, you'll get it in few days. Bye then.